Hello everyone. Today I am going to explain the concept real numbers, fundamental theorem of arithmetic, and how to find the HCF and LCM of the numbers using prime factorization method. Real numbers consist of rational numbers and irrational numbers. So rational numbers can be expressed in the form of P upon Q, where Q is not equal to 0. And irrational numbers can't be expressed in the form of P upon Q. The examples for rational numbers are 3 upon 5, 2 upon 7, 7 upon 3. So these are the examples of rational numbers. And irrational numbers are the root of all prime numbers. Rational numbers are of two types, fractions and integers. So here these numbers are all fractions since it is in the form of P upon Q. So when Q is equal to 1, those numbers are integers. For example, 2, 22, 11, 5. Can you see? For these all numbers, the denominator is 1. So these numbers are said to be as integers. So now integers are of two types, positive integers and negative integers. So the positive integers means all the positive numbers 3, 5, 52, 75. So these all are positive. So we say it as positive integers. And here negative integers means -2, -7, -12. So these all are negative numbers. So these are negative integers. Now the positive integers can be expressed as the whole numbers and natural numbers. So natural numbers all are the counting numbers. That is 1, 2, 3, 4. So these all counting numbers are natural numbers. So to these all numbers, if we include 0, then that becomes the whole numbers. So real numbers are the collection of rational numbers and irrational numbers, and rational numbers consist of fractions and integers, and integers we have positive and negative, and positive integers means whole numbers and natural numbers. So these all are real numbers. So now let's see what is a fundamental theorem of arithmetic. Fundamental theorem of arithmetic means every composite number can be expressed as the product of prime numbers which is unique. So for example, if I take the composite number that is 20, so and the prime factors of this 20 will be 4 5 is 20. So 4 is 2 square into 5. So the prime factors of this 20 is 2 square into 5, which is unique. So why the word unique is being used is 20 can't be equal to 2 cube into 5. So if I write these factors, and we know that 2 cube into 5 is 40. So that is the reason here the prime factors of 20 can only be 2 square into 5, which is unique. Now see how to find the HCF of two numbers. Here I have taken the two numbers as A and B. So it will be equal to product of the smallest power of each common prime factor in the numbers. So for example, if I take the numbers as 45 and 150, so the prime factors of this number will be, we know that 45 is 5 into 9 and the prime factors of 9 is 3 square. And here 150 is 2 into 75 and 75 is 3 into 25 and 25 is 5 square. So these are the prime factors of 150, and 5 into 3 square is the prime factor of 45. So as I said here, to find the HCF, it is the product of the smallest power. of each common prime factor. So here if I compare these two prime factors, here the numbers which are common are 3 and 5. So HCF will be equal to I will write both the common factors, that is 3 and 5. So here we need to take the smallest power. Can you see? To find the HCF, we take the smallest power. So if I see here the power of 3 is 1 and here the power of 3 is 2. So we'll take 3 with power 1 and here the power of 5 is 1 and here the power of 5 is 2. So I take the 5 with the power 1. So the HCF is 3 into 5, that is 15. So this is the way we find the HCF. To find the HCF, we take the common factor with smallest power. Now to find the LCM of the two numbers which I have taken it as A and B, it is the product of the greatest power of each prime factor involved in the numbers. So if I take the same example here, 45 and 150. So to find the LCM, we take all the prime factors which are involved in the number. That is, if I say the prime factors, if I say 5, 3, and if I see this number, 2 is also there. So we'll write all the prime factors which are involved in both the numbers. So here, and we take the greatest power. We take the prime factors with greatest power. So if I compare this 5, here the greatest power is 2. So I will write here 5 square. And if I see this 3, the greatest power is 2. So I will write 3 square. And if I see this 2, since here 2 is not there, that means it is 2 to the power of 0. So the greatest power is 1. So I will write here 2 to the power of 1. So the LCM will be 25 into 9 into 2. If you multiply these all, you get 2 into 25 is 50 and 50 into 9 is 450. So the HCF is 15 and LCM is 450. So I repeat, to find the HCF, we take the common factor with smallest power, and to find the LCM, we take all the prime factors with greatest power. So we got the HCF as 15 and the LCM as 450. Here, when we multiply the HCF of the two numbers with the LCM of the two numbers, that will be equal to the product of the two numbers. Since the HCF for the two numbers, that is 45 and 150, is 15 and 450. So the HCF is 15 and the LCM is 450. And the two numbers, that is A and B, are 45 and 150. So you multiply and check, it will remain the same. 15 into 450, when we multiply, we get the value as 6750. And when we multiply 45 into 150, we get the same value as 6750. So we say that the product of HCF and LCM will be equal to the product of two numbers. Now let's move to the next concept. A to the power of n, where n is a natural number, will end with the digit 0 if 2 and 5 both will be the factor of the given number, that is A. So if I take the number as 10, so the prime factors of 10 will be 2 into 5. If I take the number as 20, then the prime factors of this 20 will be 2 square into 5. If the number is 30, then the prime factors of this number will be 3 into 2 into 5. So I think you are able to see here, since this number is ending with the digit 0, and for these numbers, the prime factors includes 2 and 5 both. If I take the number 55, and the prime factors of this 55 are 5 and 11. So here, can you see here, this 55 does not have both 2 and 5 as a factor. So this is not ending with the digit 0. So I think it is clear to all. If the numbers have both 2 and 5 as a common factor, then they end with the digit 0. And if the numbers does not have both 2 and 5 as a common factor, then it will not end with the digit 0. So let's take the example. Let's check whether 15 to power of n end with the digit 0. So here, since the prime factors of 15, we can write it as 3 into 5 to the power of n. Since this 15 does not have both 2 and 5 as a factor, therefore it will not end with the digit 0. So write this way, since 15 to power of n does not have both 2 and 5 as a factor, therefore it does not end with the digit 0. Hope the concepts are clear to all of you. I will come up with extra questions covering these concepts in the next video. Do like, share and subscribe the channel to get updated with the upcoming videos. Thank you.